children. Welcome to the second module of our chapter Force and Laws of Motion. I hope you all are fine and completed the topics which we have discussed in our first module. In our first module, we already discussed about force, its effects, balanced and unbalanced forces. Today, we are going to learn about Newton's first law of motion and inertia. So, let's start.
Here I am explaining Galileo's experiment with inclined planes which leads to Newton's laws of motion. In his first experiment, Galileo studied the motion of marbles on an inclined plane. He observed that when a marble rolls down an inclined plane, its velocity increases as shown in figure A. Here the marble falls under the unbalanced force of gravity. The velocity of the marble decreases when it rolls up the inclined plane against the force of gravity as shown in figure B. From these observations, Galileo argued that the velocity of a marble rolling on flat horizontal surface should remain constant. To test his ideas further, Galileo used double inclined plane. He observed that when the inclinations of the planes on both sides are equal, then the marble rolled down from one plane from certain height will climb to the same height on the other plane. If the angle of inclination of the right side plane were gradually decreased, then the marble would travel larger and larger distances to reach the same height. Ultimately, if the right side plane were made horizontal, the marble would continue to travel forever to reach the same height from which it is released. No unbalanced force acts on the marble in this case. From this experiment, he concluded that a body moving with a certain speed along a straight line path continued to move with the same speed along the same straight line path in the absence of external force. But in practical situations, the object stopped due to the force of friction, which always acts opposite to the direction of motion. Sir Isaac Newton further studied the ideas of Galileo's experiment and arrived at the three laws of motion. Newton's first law of motion states that every body continues to be in its state of rest or of uniform motion along a straight line unless an external unbalanced force acts on it. The tendency of a body to remain in its state of rest or of uniform motion along a straight line till an external unbalanced force acts on it is called inertia. So that the first law of motion is also known as law of inertia. Inertia are of three types: inertia of rest, inertia of motion, inertia of direction. First I will explain about inertia of rest. It is the tendency of a body to continue the same state of rest until it is acted by an external force. In the experimental setup given here, when we give a sharp horizontal flick on the card with a finger, the card comes into motion, but the coin tends to remain in its state of rest due to inertia of rest and so that it falls into the tumbler. The same way, when a bus starts suddenly, a standing passenger tends to fall backward due to inertia of rest because along with the bus, the lower part of his body set into motion, but the upper part of the body has the tendency to remain in its state of rest due to inertia of rest. Similarly, when we beat a carpet with a stick, the dust particle comes out due to inertia of rest. Next, inertia of motion. It is the tendency of a body to continue the state of uniform motion until it is acted by an external force. See the figure given here. When we apply brakes suddenly while driving a car, the car slows down, but our body tends to continue the same state of motion due to inertia of motion. This may cause injury to us by impact or collision with the panels in front. Safety belts are worn to prevent such accidents. Next, inertia of direction. It is the inability of a body to change by itself its direction of motion or the tendency of a body to continue the same direction until it is acted by an external force. For example, if a car takes a turn at a high speed as shown in the figure, we tend to get thrown into one side because our body tends to continue in the same straight line motion due to inertia of direction.
Let's see some more examples of inertia. In the first picture, you can see the apples are falling down when we shake the tree. The tree and the apples are at rest initially. When we shake the tree, we are exerting an external unbalanced force to it. And as a result, it sets into motion. But the apples, which are initially at rest, will not be receiving this force and having the tendency to continue in the state of rest due to inertia of rest. So they are falling down. This is the same reason behind the dried leaves are falling down when we shake the branches of a tree. The second picture is falling the coin inside the glass when we flick the card, which I explained earlier. In the third figure, you can see some people are cleaning the carpet by shaking it. When we shake or beat the carpet with a stick to clean it, we are exerting an external unbalanced force to it. The carpet is set into motion, but the dust particles have the tendency to continue in the state of rest due to inertia of rest, so they come out. So these three are examples of inertia of rest. Now see the fourth picture. The body of the person is in the state of motion along with the vehicle. But when the vehicle comes to stop by hitting on the wall, he will be thrown to front because his body has the tendency to continue in the state of motion due to inertia of motion. Next, see the sixth picture. Here, when the vehicle is taking a turn immediately, the people are thrown to outward the turning because of inertia of direction. Our body has the tendency to continue the straight line motion due to inertia of direction. When the engine applied an unbalanced force to change the direction of motion of the car, we slip to one side of the seat due to inertia of direction. Fifth figure illustrates the relationship between mass and inertia. Mass of an object is a measure of its inertia. More massive the object, more will be the inertia or tendency to continue in the same state. You can watch the next video to make it more clear.
To understand inertia, we need to look at Newton's first law of motion again. Here it is. In simple words, this means that objects tend to keep on doing what they are doing. It is the natural tendency of every object to resist change in their state of motion. If they are at rest, they would prefer staying at rest, and if they are moving at a constant velocity, they would want to continue doing so. This tendency of objects is called nothing but inertia. It's the natural tendency of an object to resist change in its state of motion. Yes, you already knew what inertia is. And yes, Newton's first law of motion is also called the law of inertia. Do you think all objects have the same inertia? All objects resist changes to their state of motion, right? So all should have the same inertia, correct? Well, not really. Because inertia tells us how strong an object's tendency is to resist change in its state of motion. Think of it like this. There's a tiny brick kept on a table next to a relatively larger and a heavier brick. Which one do you think would be easier to push? Without doubt, the tiny brick, correct? Yes, but why is that? It's because the heavier brick's tendency to resist change in motion is more. The heavier the object, the more is its tendency to resist the change in motion. The more mass an object has, greater will be its inertia. So if we apply equal force to both these bricks, the tiny brick will move further as compared to the larger brick. The heavier brick has more inertia. How can we relate inertia and mass? Inertia is the tendency of an object to resist changes to its state of motion, and the mass of an object is the measure of its inertia. In the next part of this video, we will understand this relation with a few interesting examples.
Children, let's see some questions based on today's topic. Question number 1. State Newton's first law of motion. Question number 2. Define inertia. You can write the answers of these two questions in your notebook. Question number 3. Give reason. A. A standing passenger happens to fall forward when a bus suddenly stops. B. When we shake the branches of a tree, dried leaves fall down. C. We tend to get thrown to one side when a motor car makes a sharp turn at a high speed. Try to find the answers of these questions and learn it. I repeat, write the answers of the first two questions in your notebook. So today we are concluding our topic with this. Thank you.